All right. So, in the last couple of videos, we looked at an introduction to process analysis and performance measurement. How do you perform? How do you measure the performance of a process? So, what we'll do next is we'll look at a few examples of processes and see how we capture some of these metrics and talk about processes and actually measure the performance of some of these processes, right? So let's take the example of making bread, right? So there are two steps involved in making bread. You prepare the dough and you bake the loaves, which is part of bread making, and then you package the loaves and you send them out. Now, in this example that we're using, you take the raw material, which is inventory, right? So that's why it's represented as an inverted triangle. Then you make bread. So bread is made in batches of 100 loaves, and we know that from the data that's given to us, we can make 100 loaves in 1 hour, right? So it takes 1 hour to make 100 loaves. Now, once the bread is made, you probably have them on trays. You put them aside to let them cool and whatnot. But once that's done, then you package them, and you can package all 100 loaves can be packaged in 3/4 of an hour, or 0.75 hours to package all 100 loaves, and then you have finished goods inventory. So we see that it has a utilization of 75% and whatnot. Why that is, we'll talk about that in a second. So the question here is, how many of these loaves can you make in 1 hour, right? So how many loaves can you make in an hour? How many loaves can you pack in an hour? So what is the capacity of this process? So if I were to run this bread making process, how many loaves will I be able to make in 1 hour, right? So here the idea is very simple. So I can keep making bread. So yeah, it takes me 1 hour to make 100 loaves of bread. So as soon as the bread is made, it goes into work in process inventory, right? So once I make those 100 loaves, I can immediately start packing them. Now I will be able to finish packing all 100 loaves before all of the 100 loaves from here even get into the work in process inventory, right? Because this is much faster. So this is a much faster process of the process, and then this is the slowest part of the process, and so this is called the bottleneck. So bottleneck is the part of the process that is the slowest, and that is the one that usually tells you what is the capacity of your process. And the capacity of this process is per hour. So if you're looking at capacity per hour, it is 100 loaves. So you can make 100 loaves in an hour. Even though you can technically package 125 loaves in an hour. So if it takes 3/4 of an hour to package 100 loaves, in 1 hour you'll be able to package 133 loaves, basically, right? So you can package more loaves in an hour, but you can only make 100. So you can only package 100. And that is the capacity of the process. And the bread making has a utilization of 100% because you keep making bread continuously and you don't have to stop. And you cannot stop because if you stop, it'll slow down the whole process. That's the bottleneck. So whenever you have a bottleneck of part of process, that part of the process needs to keep running continuously, otherwise the whole process gets slowed down. But packaging, you will not be using it continuously, you'll only be using it say 75% of the time, right? And that's how this process works. That's the bread making process. Now, suppose that we see that packaging, we can package way more loaves than we can make loaves. So you say, hey, instead of having a single bread making machine, what if I had two bread making machines, right? Then what happens? So if I have two bread making machines, now I can produce not 100 loaves, but 200 loaves in 1 hour, right? So as you can see here, the calculations here are being done per shift. So let's do some of the calculations per shift. So what is the output for this process per shift? So if you look at per shift, you are doing times 8, right? So why am I doing times 8? I'm doing times 8 because 8 hours. So that's how long the bread making process will work. So if I'm running this for 8 hours, I can make 800 loaves of bread, and I can package 800 loaves of bread, and that is the total capacity of this process. But instead, if I double my bread making, so instead of having a single machine doing bread making and single machine doing packaging, what if I double my bread making? That is, I have two parallel bread making machines in which I can make bread, and I also run this shift 3 times. So I'm making bread. I'm going to run these two bread making machines for 2 shifts, and I'll run the packaging machine for 3 shifts. Then what happens? Well, because I have two bread making machines, I can make 200 loaves every hour, and I'm going to run those for 8 hours. And because I'm running 2 shifts, I'm basically running them for 16 hours. So that produces 3,200 loaves of bread through the 2 shifts using both my machines. And if you look at cycle time, if you look at the packaging part, so that produces 133.33 um, loaves of bread per hour times 8 hours times 3 shifts, and that will give you 3,200 loaves also. So this process is called balanced because every part of the process has the same capacity. So in this case, so if I were to run 2 and 3 shifts here, what would happen? So I have a single bread making machine and a single packing machine. So if I run 2 shifts here, that mean I can make 200 loaves per hour. And if I'm running 2 shifts with a single machine, that'd be 8 hours times 2, 16 times. So I can produce 1,600 loaves of bread. And what about packaging? So that'll be 400. So it's 133.33 times 3 shifts. That'll be 400 loaves of bread. So I have a capacity to pack 400 loaves of bread. I'm sorry, 400 times 8. So I'll have capacity to pack 3,200 loaves of bread, but I'll only have a capacity to make 1,600 loaves of bread. So I can pack 3,200 loaves of bread, but I can only make 1,600 loaves of bread if I ran the same 2 and 3 shifts with a single machine. So my bread making thing is not balanced because one part of the process has a capacity of 1,600, the other has a capacity of 3,200. But if I have two machines and then I run 2 shifts, now I can have the capacity of this process be 3,200 with every part of the process having the same capacity. Right? And that's the bread making example. Now let's look at the restaurant example. So consider a restaurant in a casino, in the same casino. Managers have set up a buffet arrangement where customers can serve themselves, and a buffet is continuously replenished to keep items fresh. To further speed the service, a fixed amount of is charged for the meal. Customers take an average of 30 minutes to get their food and eat. They typically eat in groups of either 2 or 3 at a table, and the restaurant had 40 tables. We are asked to calculate what is the maximum capacity for this restaurant. So the restaurant can accommodate 160 people at a time. So how do we know this? So each customer takes about 30 minutes for food, and the restaurant has 40 tables. So we can easily calculate that the restaurant can accommodate 160 people at any given point in time. So it might be more convenient to measure capacity in terms of customer parties, and this is how the capacity will be used, right? So on an average, a customer party has 2.5 individuals because sometimes it will be 2, sometimes it will be 3, and the average seat utilization will be 62.5%. And that's a pretty straightforward number to calculate. Now, what's the cycle time? So total cycle time will be when operating at capacity, it is 0.75 minutes, and I can calculate that because 30 minutes divided by the 40 tables that we have, the operating capacity is 0.75 per minute. That's the cycle time. And then, of course, I can calculate the capacity also, right? So these are all very simple numbers to calculate. This is not a difficult number to calculate. And if you have this extra information about how parties arrive in different parts of the hour, we can do more involved calculations for this. We don't have to. We don't have to do simple calculations. We don't have to do the same calculation for every hour. We can do it separately for each of these hours, and this is a very common sort of thing that gets done. Right? So the capacity is 80 customer parties for two parties per hour. Given the given the data that we have right now, and so with this, we can, based upon the parties that are arriving, we can calculate what's going on. Now this we can do better when we do this. Will do a lot more when we do, if we end up doing a discrete event Monte Carlo simulations later on. But right now, this is a simple example of how you can analyze a process and calculate the capacity of a process, right? So again, there are more examples here. They're all so if you look at the textbook, I'm sorry, I think I had the textbook somewhere here. So if you look at the textbook, these are all I'm sorry, these are all process analysis examples. So the bread making process is here, the restaurant process is here, and the transit bus operation process is here. So all the examples are right here, and you can look through them to see exactly how the calculations are done. But the calculations are pretty straightforward. They're not complicated at all, right? So what I'm going to do is I'm going to end this here. We'll do more of this when I see you in person in class. But remember, when you have a process like this, the way you calculate the capacity for the process, what is the current maximum output for the process? Say, for example, if you look at Daffy Dave's sub shop, there are 4 steps in this process. You first take the order. You make sub sandwiches. You take the order. It's 1 minute to take the order. Then you slice the bun and you add meat and cheese, and that takes 3 minutes per order. And finally, you add the toppings and condiments. That takes 4 minutes per order. And finally, you bag the order, which takes 2 minutes per order, right? So if you want to calculate the current maximum output for this process, how do you calculate that? Now, we will make some simple assumptions. We will assume that we are working in 8-hour shifts, right? So if you're working in 8-hour shifts, how many subs can you make in a day? That's what you want to calculate. Remember, look at all the processes that you have and look at the one that takes the most amount of time. That is your bottleneck, right? Here, adding toppings and condiments is the bottleneck. It takes 4 minutes per order. Everything else takes less, which means that whatever capacity you get for this particular part of the process is the capacity for the whole process, right? So if I'm just looking at taking orders, how many orders can I take in a whole day, right? I can take one. It takes 1 minute to make an order. So in 1 hour, I can take 60 orders. And if I'm running an 8-hour shift, I can take orders. I can take 480 orders in a day. So I can take 480 orders in a day. Now slicing the bun and adding the cheese and whatnot, that it takes 3 minutes per order, which means that in 1 hour I can do 20 of these. So I can slice and add cheese for 20 of these. So if I'm doing 20 per hour, and with 8 hours, the capacity is 160. The bun and meat part of the process is 160. Now the adding toppings and condiments, that is 120. Again, you do the same way. It's 4 minutes per order. In 1 hour, you can do 15 of these. 15 times 8 will give you 120. And finally, bagging the order takes 2 minutes, which will give you 240. So of the 4 operations that you have, this is the one that you can do the least, because this is the one that takes the longest. So the capacity of the process is 120 because that is the bottleneck, right? Now, if Dave added another person here, instead of a single person adding condiments and toppings, if there are 2 people who are doing it in tandem, then what happens, right? If 2 people are doing it in tandem, then what happens essentially is you're doubling the capacity of the toppings and condiment layer, which means that now the bottleneck is not topping and condiments anymore. The bottleneck becomes bun and meat, because by doubling this, the capacity became 240, right? So if this is 240, this is 240, this is 480. The condiment, the bun and meat section now becomes the bottleneck. So the capacity of the process, by adding another person, you have not doubled the capacity of the process. you've only essentially increased it, say, by 33%, right? So you increase it by 40, which is a third of that. So you've increased the capacity by 33% by adding another person, right? So now the bottleneck is 160, and so that's the output. Now, if the order taking station goes from 1 to 2 minutes and bun and meat goes from 3 to 2 minutes, then what happens? So if order taking goes from 1 to 2 minutes, bun and meat goes from 3 to 2 minutes, and you're adding two people here, everything now takes 2 minutes essentially. So all the different parts of the process will be 2 minutes. Oh, if you don't have two of these, this is still the bottleneck. But if you have two people here, then everything will be 240, 240, 240, and you can make 240 subs in a day. Now, this is assuming that you get 240 customers and you continuously keep making subs, but that's obviously not true in real life, but that's the capacity of the process, right? Right. So, and that's the idea. So, is there a benefit? So, is there a benefit if we shift 1 minute of work from condiments to, say, bagging? So, if I shift 1 minute of work from condiment to bagging, will it help? So now condiments will be 3 minutes, but bagging will also be 3 minutes. Will that have an effect on the process? Yes, it will have a huge effect because whenever you change anything that has to do with the bottleneck, it has a huge effect on the process, right? So by bagging, condiments goes from 4 to 3 minutes and bagging goes from 2 to 3 minutes. Now this is a benefit. Now the capacity of the process becomes 160, right? So bun and meat is 160, toppings is 160, and bagging order is 160. So basically the capacity went from 120 to 160. So at this point, if you want to increase the capacity of the process, all you have to do is add one extra person in each of these. Two extra people in each of these, then you can make the capacity of the process 480. So if you added one extra worker here, it'll become 320, 320, 320, which is a huge increase, right? And if you add if you add 6 more people, you can make it 480. In which case, the whole process will be balanced. Yeah, that's it. So that's a simple example here of a process. Right? Now, like I said, we'll do more of this when I see you in class next week. And this is it for the video section of this week, right? Take care.